Hello, mathletes. We are here with Math It Up 2000, and we are going to be working on the percent proportion today. All righty. So, proportions are a very, very, very useful tool because, as we already know from working with proportions, there is a relationship that we can utilize to help us solve. So, let's think about the percent proportion in particular. What's going to be true of the percent proportion is it's always going to have a denominator of 100 here because we're going to be working with a percent number. For instance, 50% we know means 50 out of 100. So that's how we're going to be using our percent number here in the proportion. And we'll go over examples of that. So if we see a 50% in our problem, we know that that 50, the percent number, will go right here over that 100. All right. And then we have two more parts of our percent proportion. And this part is going to be the portion. And this part is going to be the whole. Now, what we have to remember when we get into this higher level math is that a portion can be bigger than the whole. It sounds silly, but it can happen. This also could be thought of as maybe a total if we're doing word problems, but there are some words that are helpful for us, and you will see these a lot when you look at proportion solving, and that is that the is over the of. Because when we take something of a number, that's usually our total, our whole. So this is how we would set up a proportion. And let's go ahead and look at a problem so that we can see this in action. So what is 20% of 45? That's a proportion problem. That's one type. There are three types. That is one type. So let's take these out and let's see if we can identify what goes where. So the easiest part of this by far is identifying whether or not we have a percent number, and we do. So that percent, that 20% turns into a 20 here because 20 out of 100 is 20%. So that's check. We've got our percent number. And now we're going to take a look and see what we have and what's missing. What are we going to be solving for? So as we look at that, we see that we have what is. What is? We don't know what the is. So that is what we're going to be solving for. What is? That is our part. And here we have of 45. Of 45. So some part of 45. So 45 is our total, our whole, our of. And there, excuse me, and there we go. So now we know about the special thing that allows us to use proportions, and that is that the product of these two numbers is equal to the product of these two numbers. And because that relationship exists, we can use this to solve. So I like to start with my x, so I'm going to do 100 times x here, and 45 times 20 here. So that would simplify 100x stays as is. This will simplify to 900. And now we just have a simple one-step equation here. We're going to get that x by itself by turning that 100 into a 1. As 100 over 100 is just 1. Anything over itself is 1. Now I have 1x, which is the same as just x. And 900 divided by 100, of course, is 9. So x is 9, and what does that mean in terms of our problem? 9/8 is 20% of 45. We answered the what. 9 is 20% of 45. So in this example, we solved for the part. The part was missing. All right, let's take on another example. Get rid of this guy and get a new example up here. And our next example is what percent, I'm going to just use my percent symbol there to represent percent, of 25 is 4. Okay, let's see what we have here. So I'm going to set up my proportion. I know that this second denominator is always going to be a 100. And now I'm going to scan my problem to see if I have percent number. It looks like the percent number is missing. So that is what I'm solving for. Now I just have to decide which one of these is the part and which is the whole. And again, don't be fooled by small number is the part, large number is the whole. It may be true this time, but it is not always true. So let's look at our problem here. What percent of 25 is 4? Of 25, that is sounding like my whole, and this is sounding like my part. We had those words, those helper words, is over of, is 4 of 25. What percent of a 25 is a 4? There we go. Now we can use that special magic that proportions have, and we can use that to solve our problem. 25 times x is going to be equal to 4 times 100. We'll just simplify that right away to 400. We have our simple one-step equation here. Got to turn 25x into 1x. So we put 25 over 25. That turns into a big 1. And that leaves us with 1 times x, which is just x. And 400 divided by 25 is 16. All right, so let's see what we have here. What percent of 25 is 4? So our answer really isn't a 16. X equals 16, but we know we're solving for a percent. So 16% of 25 is 4. And that is truly our answer. So this is the one we have to be a little careful about when we're solving for the percent. When we get x, we know we have to turn that into a percent. Okay, so this time we solved for a missing percent. And that is the second type of problem that we can have with percents. And now we're going to look at the third type of problem that we can have, and that is when the whole is missing. The total, the whole. So let's look at this problem. So this one says 12 is 60% of what number? So again, we're going to look for our easiest piece here and see if we have a percent number. And we do. It's right here. So we're going to put that 60, the percent number, not the percent symbol, doesn't belong there, the percent number over the 100. And now we have to just see what we're solving for and what we have. So 12 is, that's that helper word, is 60% of what number? That sounds like a total, a whole, and 12 sounds like the part, and that is and of is helping us out there. So 12 would go here. We are solving for the whole this time. And let's go ahead and use our cross multiplication with our proportion. And that becomes 1200. And I would divide both sides by 60. And again, 60 over 60, anything over itself equals a 1. And 1 times x is just x. And of course, 60, and I can do that real quick. And 6 goes into 12 twice. There we go. And our answer is 20. So 12 is 60% of 20. 12 is 60% of 20. All right. So now this time we've solved for the whole. So those are the three types of percent problems we can have. We can be solving for a part, which would be here. We can be solving for the whole, which would be here, or we can be solving for the percent. But it doesn't matter which type you have. They all fit into this proportion, and that's what makes it great. Okay, let's go ahead and move on here. So what if we have a word problem? So a word problem can be something like this. 30% of the 240 baseball cards sold for over $100 each. Those must have been really awesome baseball cards. How many cards sold for over $100? There you go. Now it's a word problem. So let's go ahead and set up our percent proportion. Again, we know that 100 is going to be here no matter what. And let's scan our problem and see if we have a percent number, and we do. We have a percent number right here. So we know we're dealing with 30%. So that 30 goes over 100. That's how it becomes a 30%. All right, so we have a couple of numbers here. We have a 240 and we have a 100 here, $100. So 30% of the 240 cards sold for over 100 each. Again, we do have those helper words. Sometimes they help us with word problems. Sometimes they're not helpful. But in this case, we do have of the 240 baseball cards. So I'm thinking that is my total. So 30% of the total sold for 100 each. How many cards sold for 100 each? So that is that portion of the total. Now we don't have our is word here helping us, but we do have the of, and we really have to think in terms of what makes good sense. So here's our problem, how it sets up. We are solving for the part. So we're going to go ahead. I would like to use my x first, so I'm going to do that multiplication problem first. I'm going to line up my equal signs. I'm going to do this second. We're going to simplify this side to be 7,200. Do that math. Divide both sides by 100 to turn that x into 1x. This turns into a big 1. X is going to be equal to 72. So 30% of the 240 baseball cards sold for $100 each. That means that 72 cards sold for $100 each. So that's the sentence that answers this word problem. So a pro tip here, sigmas take a moment to see if their answer is reasonable. Now, it won't always mean it's right, but it could mean it's reasonable. So let's take a look at this. We have 240 cards. We know that 30 is about 1/3, right? 30% is about 1/3. If I divide 240 by 3, that would give me 80, right? So does it seem reasonable that that might be our answer? It does. Doesn't mean it's right, but it does mean that you've at least checked to see if it's a reasonable response to the question you have. All right, we are going to head into check and correct now. We have 3 check and correct problems here. So I invite you to stop the video and do these 3 problems now, and then start again and compare your work as I work through them to make sure that you're on track and to make any corrections if necessary. So you can do that now. We'll see you back in a few minutes. Welcome back. We're going to now go ahead and look at these problems and get our answers. Please make sure to check and correct your work if necessary. So let's set up our percent proportion. And of course, we're always going to have that 100 under that second fraction or ratio. So what percent of 180 is 54? Well, I don't see a percent number there. That means that's what we're solving for. So again, let's find our part and our whole. And we can't always assume that the part is going to be smaller than the whole. It isn't always. So make sure we're using our guiding words. What percent of 180? That sounds like the whole is 54. That sounds like the part. And there we are. Now we can use the magic of proportions to solve this problem. Start with our x. 180x equals 54 times 100. That's easy to simplify. And then we're going to divide both sides by 180 so that x is isolated all by itself on one side of our equation. And of course, 180 over 180, anything over itself turns into a big 1. And 1x is simply x. And 5400 divided by 180 is 30. So x equals 30, but remember, when x is here, then we know that this number is not 30. It is actually going to be an answer of 30%. So kind of think of it about like as a word problem. We get x equals 15, but the answer is really 15 cows, 15 donuts. So in this case, it's 30% because that was our percent number. Okay, so that's our first one. Our next one is 52% of what number is 26? Take a look at that one. We got the 100 there. And I'm scanning, and there we go. That's my percent number. That's the easy one. I'm going to throw that right over 100. Now I've got to decide what I have and what I'm missing. So I've got my of what number is 26. Those guiding words are very helpful. We are solving for the whole here. So again, I like to start with my x. So I'm going to do 52x equals 26 times 100. It's easy for me to simplify, 2600. And now we're going to divide both sides by 52. And again, anything over itself turns into a 1. It's very helpful. 1 times x is just x. And 2600 divided by 52 is 50. So the answer here is 52% of 50 is 26. And again, we talked about in the last video, checking answers or making sure answers are reasonable. So is 50 a reasonable answer? So 52% of a number is 26. Well, is 26 about half of 50? It is. So it is a reasonable answer. And lastly, we have a word problem here. If May got 84% on her test questions correct, and there were 150 test items, how many test items did she get correct? So it's always a little more difficult when you're set up with a word problem. It just makes it a little harder to pick out those pieces. So we're going to have to really look at this. Well, the good news is we have 84%. That always goes there. That's easy. So our percent is there for us. Now let's take a look at this. The test questions, she got 84% of them correct on a test that had 150 items. That sounds like a total. So again, my total goes with the 100 here, and the portion, the 84%, is lining up with what number is going to give me that 84%. That is my part. So let's go ahead. We're going to go this way first to get our X on the left side. And then over here, we're going to do 150 times 84. And that's going to give us 100x. We're going to simplify this side. And that's going to give us 12,600. We'll divide both sides by 100. That turns into a 1. And x is going to be equal to 126. Again, let's look if this seems reasonable. She got most of them right, over 80% right. There were 150 items. Does it sound reasonable that she might have gotten 126 right if she got almost 85% right? It does seem pretty reasonable. And that's what we want to make sure that we're looking for. So here's your on your own problems. These two problems should be done while things are fresh in your mind to exercise those skills and make sure you're trying to use all those little tips that we went through and get the right answer. And that's it for today. So peace, love, and pie to all. Bye-bye.